Good morning, Year 6. I hope you're all okay and you've all had a lovely bank holiday weekend and you're all ready to do some more learning. So, carrying on from last week, this week we're going to be starting off with multiplying fractions. So I just want you to think about the following. How is multiplying fractions similar to adding fractions? How does partitioning the mixed number into wholes and fractions support us to multiply? Do you prefer partitioning the mixed number or converting it to an improper fraction to multiply, and why? And does it matter if the integer is first or second in the multiplication sentence, and why? That just means the whole number. Okay, so does it matter if the whole number is first or second? So have a think, write down your answers, and then we'll go through some explanations. Okay, so multiplying fractions is similar to adding fractions simply because multiplying is repeated addition. So a fraction, so say it was 3/4 times by 2, it would be the same as 3/4 add 3/4. If it was 3/4 times by 3, it'd be 3/4 plus 3/4 plus 3/4, and so on. How does partitioning the mixed number into wholes and fractions support us to multiply? It just means you can do two separate multiplications. So if it was 2.5 multiplied by 4, you could do 2 multiplied by 4 and then a half multiplied by 4 and add them together. And then the next one is a preference question, so that's down to you, as long as you explained why. And then it says, does it matter if the number is first or second in the multiplication sentence? So for example, if it was 3 times 1/5 or 1/5 times 3, would it make a difference? And the answer is no, because whichever way around you do a multiplication, the answer will still be the same. And we know this because we know, for example, 2 times 3 is 6 and 3 times 2 is also 6. So it doesn't matter whether the number is first or second. Okay, moving on then. So just to recap, if we are multiplying a fraction by another fraction, we need to multiply the numerators. So on that example, we've got 2/5 times 3/4, so we do 2 times 3 is 6. Then we multiply the denominators, so 5 times 4 is 20, so it becomes 6/20. And then it says reduce the fraction, that means to simplify it. So can we reduce 6/20? Yes, we can. We can divide them both by 2. So 6/20 can be simplified into 3/10. So I'd like you to just have a go at the others, please, and if they can be simplified, please do so. So 8 times 2 is 16, 10 times 3 is 30. Can we simplify that? Yes, we can. We can divide them both by 2. So 16 divided by 2 is 8, 30 divided by 2 is 15. Next one, 35 times 2 is 70, 100 times 8 is 800, and then we can simplify that by dividing them both by 10. Can we divide them again by anything if they've got a common factor? No, there's nothing that can go equally into 7 and 80, so that's the simplest that can be. Next one, 5 times 8 is 40, and 6 times 10 is 60. We can divide both of those by 20 to make it into 2/3. Next one, 1 times 5 is 5, 2 times 10 is 20, and those can both be divided by 5 to make 1/4. I nearly said 1/5 then. And then 2 times 3 is 6, 3 times 4 is 12, and we should all know that 6/12, you can see straight away that 6 is half of 12, so that is the same as a half. And then the last one, you should remember as well that this also means of, so a half of 2/6, a half times 2/6, which equals 1/6. Okay, or if you want to do it the way we've been doing, you do 1 times 2 is 2, 2 times 6 is 12, so 2/12 is the same as 1/6. So the next step then is doing fractions times by whole numbers. And like we just said on the first slide, it doesn't matter if the whole number is first or second in the number sentence. Now on the left there you can see it says a common error when multiplying a fraction by a whole number. Because when we're doing fractions by fractions like we did on the last slide, we do the numerator times by the numerator and the denominator times by the denominator, A common mistake that people make here is that they multiply the numerator by the integer. So on the first example that they've got there, they would do 3 times 5 is 15, and then they do the same to the denominator, so they would do 4 times 5 is 20. That is incorrect. So the way to do this without getting confused, the way that we've taught you to do it in class, is to convert that whole number into a fraction. So you should know that 5 is the same as 5 over 1. So 5 whole ones is 5 over 1. So now it just becomes a fraction number sentence instead. And then we can do what we've done on the previous slide, which is numerator times numerator, denominator by denominator. So have a go at those ones, and then we'll go through and mark them. Okay, so 10 twelfths then becomes, 10 twelfths times 5 becomes 10 twelfths times 5 over 1. So then 10 times 5 is 50, 12 times 1 is 12, and then we can simplify that down into 25 over 6 by dividing it by 2. And then if you look, that's an improper fraction, so we can convert it to a mixed number by saying how many 6s are in 25? It's 4 with 1/6 left over. Next one, 2 6 times 3 becomes 2 6 times 3 over 1. 2 times 3 is 6, 6 times 1 is 6, so 6 sixths equals 1 whole 1. 5 times 5 tenths becomes 5 over 1 times 5 tenths. 5 times 5 is 25, and 1 times 10 is 10. Then both of those, so the common factor that can go into both of those numbers is 5. There's 5 5s in 25, and there's 2 5s in 10, so it becomes 5 halves. And then, because that's an improper fraction, we can convert it to a mixed number. So we say how many 2s, or how many halves are in 5. There's 2 whole ones with 1 left over. A half times 4 becomes a half times 4 over 1. 1 times 4 is 4, 2 times 1 is 2, so it's 4 halves, which is equal to 2 whole ones. And then finally, 6 times 3 fifths becomes 6 over 1 times 3 fifths. 6 times 3 is 18, and 1 times 5 is 5. Again, it's an improper fraction, so we say how many 5s are in 18? There's 3 with 3 left over, so it's 3 3 fifths. Okay, so there's some fluency questions here, and they've got some pictures to help you to try and understand it a little bit better. So have a look at the pictures. Some of you, I know that the pictures just throw you completely and you'd prefer to do it without the pictures, but others look at the pictures and think, right, now I understand it. So have a look at them, have a go. Like always, any that you can't do, just leave them out, fast forward to the explanation and see if that helps you at all. Off you go. Okay, so the first one then, it says 4 times 7, 8. So 4 times 7 is 28, and 1 times 8 is 8. So you can see there as well, for the 4 times 7 eighths, I've changed my 4 into 4 over 1 before I've done any working out. So then 4 times 7 is 28, 1 times 8 is 8, and then that becomes 3 4 eighths, because how many 8s go into 28? It's 3 with 4 left over. And then we can simplify that. Remember, when we're simplifying, we don't do anything to that whole number, it stays the same. So the 3 stays the same, but 4 eighths can become a half. Going across then, 3 times 2 thirds, so that can be written as 3 over 1 times by 2 thirds. So 3 times 2 is 6, 1 times 3 is 3. 6 over 3 is the same as 2 whole ones. And if you look there, you can actually count them, so you can see how many thirds you've got. And you can clearly see there in red that there are 6 thirds. And then the last one is 2 fifths times by 7. So that becomes 2 fifths times 7 over 1. 2 times 7 is 14. 5 times 1 is 5. And then to convert that into a mixed number, we say how many 5s are in 14? It's 2, remainder 4, so it's 2 4 fifths. Now for this one, we've got a mixed number and we're multiplying it by a whole number. So it says Eva partitioned her mixed number to help her to calculate it. So she partitioned 2 3/5 into the whole number first. So she did 2 times 3, which was 6. Then she did 3/5 times 3, which was 9/5, which is an improper fraction. So she converted that back to a mixed number. And then she got both of her answers. So 6 whole ones plus 1 whole one and 4/5 equals 7 4/5. So use Eva's method to calculate the following questions. So using that then, we can say for 2 5/6 times by 3, if we take our whole number first, so 2 times 3, which is 6, then if we take our fraction, 5/6 times 3, so that becomes 5/6 times 3 over 1, which is 15/6, which equals 2 3/6, which can be simplified down to 2 1/2. Then get our two answers, so 6 plus 2 1/2, which equals 8 1/2. So that's the answer to the first one. For the next one, you should have done the working out, and the answer you should have got was 7 1/7. Then you should have got 8 whole ones and 4 2/3. For this method, so it's using a different method to do the same type of question. So instead of partitioning, this one's saying let's convert your mixed number into an improper fraction to multiply. Okay, so it's the same kind of question, 2 3/5 times by 3, but instead of partitioning the 2 and the 3/5, it said let's convert that to an improper fraction, which is 13/5, then times that by 3. So it will be 13/5 times 3 over 1. So if you use that method, see if you can calculate the ones at the bottom, which you should have already done. So your 3 becomes 3 over 1, your 2 2/5 becomes 12/5, so it's 3 over 1 times 12/5, which is 36/5, and then simplify that down, convert that to a mixed number, and that becomes 7 1/5. The next one then is going to be 1 5/7, as an improper fraction is 12/7, times that by 3 over 1 becomes 36 over 7, and then convert that to a mixed number is 5 1/7. Then we've got 2 times 1 3/4, so it's 2 over 1 times by 7 quarters equals 14 quarters. Convert that to a mixed number, which equals 3 2/4, and then simplify that down to 3 1/2. And then the last one, 2 times 1 1/6 becomes 2 over 1 times 7 over 6, which equals 14/6. Convert that to a mixed number, becomes 2 2/6, and then simplify that down, it becomes 2 1/3. Okay, problem solving and reasoning. There are 9 lampposts on a road. There is a 4 3/8 of a metre between each lamppost. What is the distance between the first and the last lamppost? And I've put the lamppost there to help you. Now beware, just count how many gaps there are, because some of you are going to try and use that number 9 in your number sentence. So count the number of gaps and then do your number sentence for that one. Then it says Eva and Amir both work on a homework project. Read what they said and then see who spent the most time on their project and explain your reasoning. Off you go. Okay, so for the first one, it says there's 9 lampposts. Some of you would have been tempted to do 9 times 4 3/8. The reason I put the lamppost there is so that you could count the number of gaps. You should be able to see that even though there's 9 lampposts, there's only 8 gaps. So it's 8 times 4 3/8. So 8 over 1, and then I've used the method where we're going to convert our 4 3/8 into an improper fraction. So it's 35/8, and I've worked that out by doing 4 times 8 and then add 3. And then 8 times 35 equals 280, 1 times 8 is 8, and then I've converted that because it's an improper fraction, and I've said how many 8s are in 280 and the answer is 35. So your answer is 35 metres. For the next one, Eva and Amir both work on the homework project. Eva says she spent 4.25 hours a week for 4 weeks. And Amir says he spent 2.75 a week for 5 weeks. Who spent the most? So you're going to have to do 4 times 4.25 for Eva. So it's going to be 4 over 1. And again, I'm going to convert my 4.25 into an improper fraction, which is 17 quarters. Multiply them together, which gives you 68 over 4, or 68 quarters. And then how many quarters are in 68? It's 17, so the answer is 17 hours. For Amir, we're going to do the same thing. So 5 weeks, that's 2 hours and 3/4 a week. So it becomes 5 over 1. Convert my 2 3/4 into an improper fraction. 5 times 11 is 55. 1 times 4 is 4. And then how many 4s are in 55? It's 13, remainder 3. So it's 13 whole hours and 3/4. So who spent the most? The answer is Eva. And explain your reasoning. Your reasoning is because if I do 4 times 4.25, I get 17 hours, whereas 5 times 2 3/4 is only 13 hours and 3/4. Alex says 1/4 times 1/2 is the same as 1/2 of a quarter. Do you agree? Explain why. And you should have said, Alex is correct. Multiplication is commutative. That means that you can do it both ways round. So 1/4 times 1/2 is the same as 1/2 of a quarter, or 1/4 of a half. We've mentioned before that when times in fractions, it also means of. So 1/4 of a half is the same as 1/2 of a quarter. And if you wanted to work those out to prove it, you could do. So you could do 1/4 times 1/2, and then you could do 1/2 times 1/4, and you would get the same answer. Your answer would be 1/8. And then your last one for today. The shaded square in the grid below is the answer to a multiplying fractions question. What was the question? And how many ways can you complete the missing digits? Off you go. Okay, so there's a number of possible answers to the first one. One way that I did it was to say, right, well, first of all, I could say it was 1/6, so 1/6. And then if I get my 1/6 and split it into quarters, so it would be 1/6 times 1/4, which equals 1/24. Or I could have done the opposite of that, and I could have got my 24 squares that I've got there, and I could have split that into quarters to start off with, and then I could have split each of my quarters into 6. So 1/4 times 1/6 equals 1/24. So that just shows us, like we said on the previous page, that you can do it both ways round and you would still get the same answer. Okay, so there might be other options you could do for that, as long as your answer is 1/24 at the end. How many ways can you complete the missing digits? And it says, here are the possible answers. 2/3 times 3/4 equals 6/12 equals 1/2. 2/2 times 3/6 equals 6/12, which equals 1/2. So we already know that that green splodge at the bottom is definitely going to be a half, and we know that because the final answer is 6/12, which is equivalent to a half. So basically we need to work backwards for this. We know that's a half, and then the purple one has got to be 2. It's got to be. Why has it got to be 2? Because what do we times by 3 to get 6? So that one is always going to be 2. So we know straight away that our purple is always going to be 2 and our green is always going to be 1. So the only other numbers that there could be are for the brown and the blue. And that can be any two numbers that multiply together to make the 12. Okay? It does say you could also use improper fractions. So if you have got any that work, then that's fine. However, I don't think there are for that. And that's you done for today. Tomorrow we're going to be moving on to dividing by fractions. So if you want to have a quick look up on that this evening or this afternoon by going on to SATS Companion and looking at some of the videos on dividing fractions, then by all means go and do that so that you've got a bit of a recap before tomorrow's lesson. Enjoy the rest of your day, and I shall speak to you tomorrow.